Hi, Azamata. How are you?
I'm doing fine, thank you. What about you?
I'm well. I'm doing well.
Yeah.
Waiting on to see if JB will join us tonight.
Excuse
I
me?
look. I'm waiting to see if JB. I don't know if you know JB. He's from the class. His name is um, Jacqueline. I think I'm pronouncing it right. But he says just call him JB, and he's supposed to be here tonight as well.
Okay, I don't think I know him.
Okay. He's in groups with me. So, how have you been? How have you been over since?
Oh my God, I don't know, but I don't seem to get this at all. I mean, everything is like I don't know why, but it's kind of hard for me to understand. I've been trying, yeah. My MATLAB, is easy to get them right because you keep trying
Mhm.
until you get it right. But
Mhm. Mhm.
when I try to compare the questions from my MATLAB and the classroom homework, or maybe the one in our textbook, I don't, it's kind of different. I think
Okay.
if I can like get it for once, maybe like this week,
Mhm.
if I can clear up of what we did last week, then that could help me to go into next week.
Yeah.
But I think I'm carrying it all over and all over and going forward, and it's kind of hard. I don't know.
Okay. So what I did was I have written everything down, all the steps. You can see I use it like all the time, all the little stuff on there. But like step, and right now I'm up to 7 pages, and that's not including the first page. So I'm up to 8 pages. But like to find what we did this week, the standard deviation, standard distribution of means. Like I wrote out step by step, and then we'll go over it because it sounds like we have to start from last week um, to make sure that you understand this week.
Yes, I mean if we can go over the whole questions, like if I understand, I tell you. Then if I don't, I'll just go over them and
Okay.
let me see where I did
So
it.
let's see. Do you want to go over week three's homework or just week four?
Mm, I don't know which one first, depending your time. How many minutes do you have to
Oh,
spend?
I'm fine. Yeah, I'm fine.
Okay. Yeah, if we can quickly go over week three, then week four, though, then
Let
because
me pull up.
at my group, yeah, I try to do, but I don't really get the answer. Except here week three, I did it
Mhm.
for my group because it was kind of short and easy.
Mhm.
For the week three, it was
Right.
easy and short. This
Yeah.
week four, yeah, I think people solved it, but I see the answers, but I don't know what they solved because they just post the answers. So
Mhm. Mhm. So there's no discussion going on in your group or anything. They just post the answers and that's it. Is anybody getting 100 in participation? I wonder.
yes, I've been getting 100, but I don't know
Okay.
what I did. Yeah,
Wow.
I just try to contribute.
Yeah, that's all she's looking for. She doesn't want you. She doesn't want like the students to just come in and give their answers. She wants the students to participate. So those who are just coming in and giving answers aren't getting 100% for participation. But for me, all those little points count. Participation. They all add up in the end. So yeah.
Yeah, it does. See, I did very poor on the first quiz. It was
Okay.
76%, which is terribly poor.
Well, I'm wondering if she's going to give us a curve, and then you also have to remember, my math lab is the equivalent of a quiz. So if you screw up on one quiz but you do well in my math lab, you can pretty much not throw the quiz away, but it won't count. It won't affect your grade as bad as you think it will, as long as you do well in my math lab to kind of cancel out that quiz.
Yeah, I know, but my MATLAB is easy to get. I'm sure that I'm gonna get my MATLAB 100%.
Good.
So I'm counting more on the quizzes and the exam.
Okay, okay, good. So we need to make
Yeah.
sure that you're ready for quiz number two. So I pulled up the questions from because I hadn't even looked at last week. And let me share the screen with you so we can look at it together. Okay. Here we go.
Okay.
So let's see. Let's see. Let me look at it because I haven't looked at it either. Based on the information, rather. Okay. So the first things that we need to do for these type of problems is consider the five steps. And the first thing for these type of problems is step number 1, and that's to rewrite the question as a null hypothesis versus a research hypothesis or alternative hypothesis. So for those, is HO is the null hypothesis. That is what we automatically assume is true. Hey JB, glad to have you here.
Hi.
We're just going over. You're on mute. You can.
Yeah, I can hear you.
Let's see. I don't know if I can.
Maybe you can. Or you want to remain on mute?
Let's see. I don't know if I can get him off of mute. I don't think I should. At the top of your screen should be mute. Yeah. Okay. So what we were talking about now, JB, is going over week 3. How did you do with week 3? It's on mute. Let me see. How can I get you off mute? At the top of your screen, there should be a camera and a microphone button.
You cannot do it I think he should be able to do it.
From his, yeah.
Yes. Because I tried to see.
Let's see. Oh, wait a second. I can get it from here.
Oh, okay.
Oh, no. I disconnected him, I think. Or did he do that?
Oh, yeah. He's gone.
He's gone. Okay, well, he'll be right back, I'm sure.
Sorry.
Okay. So, going back to week 3, and the first thing we need to do is write the null or the alternative hypothesis. Did you understand the null and alternative hypothesis?
What do you mean?
Let's see. The null hypothesis is what we automatically assume is true. I wish I had a question in front of me. For instance, let's say that we're testing the heights of kindergartners, and the average height of kindergartners is, geez, I'm terrible at heights, but let's say 3 feet for a kindergartner. So if the average height for a kindergartner is 3 feet, that's your null. That's the meat of your null hypothesis. That will tell you we assume the average height of every kindergartner is 3 feet. That is the truth, and the alternative hypothesis is trying to disprove the null hypothesis. So it's a really roundabout way that they go about doing it, but this is fundamentally important to understand this step, because I've been reading forward to next week's stuff, and this is fundamental. You need to fundamentally understand the null versus the alternative hypothesis. So do you get it, or?
Yeah. I get what he said. I understand.
Okay. How about you, JB? Do you get the null and the alternative hypothesis?
He's gone again.
He's gone again. Okay. So for these questions that we're doing from last week, step number 2 is not as important, but it will be in this week that we're actually talking about. So determine the z-score to reject the null hypothesis. So from here is where the actual math and the formulas and things like that start coming in. So tell me how you would begin this problem.
With the
so let's do study A.
Because it asks about the z-score.
And it's asking. It's a three-part question. It's asking for the cutoff scores. So for question A, what would the cutoff score be?
Let me read the question based on the information. Decide whether to reject the norm. Okay, is this scores or cutoff scores and the conclusions at which the norm should be rejected? Is this score isn't that minus 1.69?
Okay, good.
And 1.69.
Let me double check. I have that all. I have all of the.
Yeah, I'm just
Are you
saying
looking
that
now?
if I get it right.
Yep. Two tails at.
Okay. Is this two tailed or one?
It says two tails, and it's at
because the minus 1.69 is two tails, right?
So it's actually going to be a 2.58 because it's two tails at a 0.01 p level. So the p level tells us 1% or 5%. So this is.
Oh, excuse me. I'm sorry. Yeah. We are talking about A right now, right?
Right. A.
Oh, okay. Right. Yeah, and the B is the two tailed.
B is two tail 5%. Right.
Okay.
And then that's going to be 196, 1.96.
96. Okay.
And then C is also two tails, but it's at 0.1.
It's the same one tail, right?
No, it's two tails. It's still two tails. And then the P level is 0.01.
I don't excuse me. I don't get it.
Okay.
D is two tailed, B is two tailed, and C is two tailed.
Let me show you what I've got here. This is how I remember it.
Can I see that? Take it a little back, close to yourself, maybe. Yeah, closer to yourself. I can't really see what you wrote there. So okay, I'm seeing 2 point what? Sorry.
Let's see if I can zoom in.
99%, and I can see everything. Okay, this one.
So this square right here, it's just this square right here that I'm talking about. The z-score square. So if you want to write it down for when we're looking for 1% or 0.01, and it's a one tail, it's going to be 2.33. It's going to be the z-score.
The cutoff score.
The z-score is going to be 2.33. If they're asking for one tail, 0.01%, it's 2.33.
The P level at 0.01, right?
Right.
Then and the two tail.
At one tail. This is at one tail. It's going to be 2.33.
The cutoff score?
Right, exactly.
What about? I don't get it.
Okay, so let's
that is 2.58.
2.58 is two tails at 1%. So remember, the bell-shaped curve always has two tails. So if the question could either be asking for just one tail, for instance, what's the percentage above or two tails? Right. So if they're asking for 0.01, then you have to say, the next question you have to ask yourself, okay, 0.01 with one tail or two tails?
Okay, so with one tail is
2.33.
2.33 and minus 2.32, right?
Exactly, right.
Okay.
And then for two tails at 0.1, it's 2.58. Right. Now when we're looking for 5% with one tail, it's going to be 1.64.
One tail, gonna be 1.64, right?
Right.
Yes, and two tailed is 1.96.
That's it. You've got it. So basically, those are the main four. Sometimes you'll see 90%, and then
Yes, there is another area that's kind of confusing. When it will say like determine the D's between 2.5% or 99%.
Yep, we'll get
When
into
it comes to the percentage, like on the normal distribution.
right. Is it this week or let me think. Percent. Uh, let's see, because I'm sure it's going to come up in this problem. So let me pull the screen back up because we figured out the very first part. And the very first part, which is A, is asking for the cutoff score. So we know for study number A, they're asking for a P level of 0.01 with two tails. So for answer A, you can go back to the little chart that you've made, and you'll see that for answer A, with two tails at 0.01, it's going to be 2.58.
Yes.
Okay. So then we write that down, and then let's go to the second question that it's asking. The second question that is asking is the z-score comparison on the sample score. So now it's asking you to find the z-score for the sample score. Do you know the formula to find the z-score for the sample score?
Z-score should be x minus m over z.
Let's say for your z-score, it sounds right. Let me double check because I have to write it all down too and make sure that it's not the other one that I'm looking at. Yep. I'm looking at the M score. Right. So it's going to be the sample score, which is 75, minus the 74. I'm looking at the second problem. 74 minus.
For which one?
For study A.
Okay.
Minus the mu, which is 67, divided by the standard deviation of 1.
So it's 74 minus 67 over 1. Just 7 over 1, so that's 7.
Is it? Okay, good. Now I'm not doing the math with you, so I'm trusting that you, and I know you can do the math. So on to part C. Now part C is just asking for the conclusion. Is your answer greater than 2.58? If it is, was it 7 or 0.7 that you found?
7.
7. So 7 is bigger than 2.5. So therefore, would we accept or reject the null?
Yeah, I would say we will reject it because it's too extreme.
Good. You've got it. Good. So let's try problem B. Same thing. First thing they're asking for is the cutoff score. So we see that they're asking for a P level of 0.05. So we go to our little chart and we look up 5, and then with two tails, so the cutoff score is going to be 1.96. So we write that down for our answer for A.
B,
Okay. We
We
move on to B, and we know our formula for B is Z equals the sample minus the population.
Minus 67 over 4. Okay. 75 minus 67. X over 4, which is 2.
Okay. And that's really close, 2. And is that bigger or smaller than 196? So would we accept or reject the null hypothesis there?
I still say we because this is my 1.96. It's close. I'll say we accept it.
It's really close. We will reject it.
We'll reject it because it's a little bit extreme.
Yeah, it's still more extreme. And what we're going to find out in the upcoming chapters is just how much extreme is too extreme. Just how much can we really say that we reject it. All right, but that's going into the next chapter. So for just to make sure that we've got it, let's look at question number C.
C.
All right, so the first thing it's asking is the cutoff score. So that's going to be 0.01 with 2 tails.
76, 74.
Okay.
74 over 4. 76 minus 74. 2 over 4. 2 over 4. 0.5.
Okay, good. So then, is that more extreme or less extreme?
It's less extreme.
Good. So does that tell us to accept or reject the null?
Reject.
We will accept the null.
Because
it's less extreme.
So the cutoff
is 2.57.
0.01 2 tau. It's 2.58. That means it's less extreme. So why should we accept it?
Let me double check. Yep, that's what. Unless I don't know. Unless the professor we haven't got.
Okay. Now I see because there's something I'm thinking of right now. Okay. Because it said if it's below minus 2.58 or above 2.58. Right? That means it's not below minus 2.58. And it's not above 2.58. So kind of in between.
Let's see.
But I have a question for you. 0.5 and minus 2.58. So which is higher?
Azamar, I have been doing math for so long, and it takes me the longest time to figure that out. How I figured it out is I actually have to draw out the chart. The bell curve is the only way I
can... So that chart, I don't even understand that chart.
No, you know how you draw the bell curve and then you plot your lines, like for question C that we're doing, we'd say 74 is the middle of the bell curve, or z-score of 1.96, and then we go and plot 0.5 and we see where that would fall, and then I plot like 2.0 and then 1.4 just to make sure I'm on the right side. And I see where it is. I shade what I'm looking for, and then that's how it takes me. Let me show you what I mean. Because I can't figure out any other way. But it's completely a math thing. But I've never been good at math. But I have to draw one of these out. The bell curve, and then I'll put my 1.96 in the center of the bell curve, and then figure out where my cutoff score is, or whatever I'm looking for. If this is my cutoff score, then 0.5 should be over here.
I don't get it. So you just draw. Okay, let me just draw it here. The normal distribution. Okay. So how do you label it? Because that is another nightmare for me. I can't seem to figure out how you guys do that.
Okay, let me draw one really quick. Say hi. Hi, baby.
Say hi.
Okay. Hi.
Bye-bye. Okay, bye. See you later.
No.
Okay, so at the center is 50, right?
I put 50 at the center.
Okay. Then let's work with this 0.5 now.
Okay.
So you do the 2%, 14%, 34%.
Right. And I just drew that in just for visuals, just to make sure that we're on the same page. So our answer, we were looking for, what was that, 2.58? Okay. So
yeah, for the cutoff.
For the cutoff. So here is 0, right? And here's -5.
Oh, excuse. So after the 50, so how do you do the 0?
This is just a make believe, but I'm gonna show you, right? So we would say that 2.58 would be 2.58 would be right about there somewhere between 0 and 25. 2.58.
How did you know?
The way I drew it out, my standard deviations of this is 25. So they go with 50 being my center. I go 25 each way.
Okay, okay, okay. So
Okay.
50, 25, 0.
Right.
Right?
It's 50 is in the center, and then I go back 25. So that's 25, and then 0. And then this one should be actually what, negative 25. This one should be.
Okay, so okay, let me just get it. 50, 25, 0. So how did you know where you get the minus 2.58?
So if we have 2.58, now we're just going to play with regular 2.58. We're not going to use negative first. We're going to look at regular 2.58. But our answer. What was our answer?
Good night. I'm sorry.
That's okay. Look, you know I had 3 kids, so I know how it is. Trust me. Okay, so our cutoff score was here at 2.58, right?
I'm not sure because I'm still asking you. How did you get it? Okay. Here is 2%, right?
2%. No, we're looking at, remember part A of our question asked us to determine the z-score. And we said, okay, well, it has 2 tails. It's 5,
which is
and then
2.58.
It's 2.58. So that's our cutoff score. So we mark it on the map. We mark it there.
Yes, but my question is how you determine where to mark up the cutoff score. So now
the map is kind of a rough estimate just to make sure it's not exact. It's just a rough estimate to make sure that you can visually see what's going on. So I just figured this is 0 here.
Okay.
This is 0, and if this is 25, it's going to be closer to 0 than it would be to 25, right?
Yes. Okay. So
if we did like little points in between each, and we marked out 1, 2.
Just to make it maybe 5, 10, 15, 20.
Right. Exactly.
Okay.
Exactly.
Okay.
All right. So then from there, after 5, 10, 15, 20, we can then divide that even further to 2.5. You know, even further if you need to go that far into it. But this is really just for visual purposes. The maps are. So then we find somewhere between 0 and 25.
Okay, and make it the cutoff score.
Right. That would be our cutoff score. Or if we say this cutoff score is 1.96, right? Because that's another one of our cutoff scores.
So we can do it closer to the 0.
Exactly. It would be even closer to the 0 than 2.58 because it's closer to 0.
Yes.
So, right. So 1.96 would be.
Yeah, I could do it here.
1.96.
1.96.
You writing it on yours? Good. So 1.96 would be even closer, right? Even closer to 0. But yet it's not closer. It doesn't mean, you know, this really, we're just looking at these numbers right now. I don't want to get confused by any of this, even though it's helpful to understand that. But so we figured out where 2.58 or 1.96, whatever our cutoff score may be.
Okay.
And we draw that out. And then let's do it a little bit further because I think that you're having some trouble with this. So let's take it a little bit further. Let's not say 100. Let's say the middle is 2, right? So our
the middle of what?
The middle of our bell curve this time is going to be 2.
Okay.
Right?
Okay.
So then over on this side we have 1, and our standard deviation is going to be 1. Okay? So then that means it's going to be 1, 2, 3, and then it's going to be what? 0 over here, and then negative 1, 3, 4, and 5. Okay? So then that's how our chart would look if we said it's 2.
Oh, so now you did it 1, 2, 3, 4, 5. Okay.
And then we can say that our cutoff score was what? 2.58, right? So we'll figure 2.58 has got to be in between 2 and 3 somewhere, right? Because
yes. Yeah. Okay. Like 2.5, then a little bit closer to 3.
Good. So then we've got the 2.58, and we plotted it here, right?
Mm-hmm.
All right, and we after doing the math, we found the z-score. X minus the mean divided by the standard deviation, and we find that the z-score is what was it, point 0.5 or point -5? Do you remember what it was? 0.5. Okay, so we look at our math, and we know that point 0.5 has got to fall.
Yes, it's on the right. I mean on the left.
Right. And so I'm sorry, I did skip a step. So before we go any further, we say if this is our cutoff score here, anything over here means that we get to reject the null hypothesis.
Oh, I see.
Okay.
Yeah. Let me just. I'm sorry. I'm fighting you with questions. Anything on the left.
Now, for our example, we'll do another one to show you what it'll look like on the right. But for our example, because we're looking for the cutoff score is 2.5. Yeah, it's over here,
which is 2.58.
Right.
While this is 0.5.
Right. So our 0.5 is going to fall in here.
Here, yes, close to 0.
Telling us that whatever we're testing over here is not normal. The medication that we're given is actually working. So whatever the null hypothesis is telling us that normal should be, our test is now telling us, this is not normal. We have to reject the null hypothesis. Okay.
Okay, but I have a question. The cutoff score is negative 2.58 and 2.58.
Okay, so if we're going to go...
Are we getting rid of the negative 2.58 and working with only 2.58?
Right. Now, that's a great question. The reason, once you get your z-score, right, and once you get your z-score, and if you've got your two possible cutoff scores, one is 2.58, one is negative 2.58. Once you get your z-score and you see that it's 0.5 or 0, whatever your final z-score is after you do your math, z equals x minus m divided by standard deviation. Once you get that math, that's the z-score that you go with. So negative 2.58 now goes out of the window because we know that it's not on that side.
Okay, so that means if I were to get negative 0.5, then I would work with negative 2.58.
Right, exactly. And that's when it would change the side of the equation. So let's do that. Right? So now our score is, what was it? Negative 0.5 now, right?
Okay.
Okay, and then before it was, okay. Now what happens with negative, and this is the reason I have to write a chart out for this, because with negative numbers, I don't want to say but it's different. It's whoever's closest to the 0. So let's start with 0 here, and we'll say negative 1, negative 2, negative 3, and we'll say 1, 2, 3. Okay? On our bell curve. So if we're doing 0, right? And then we have negative numbers over here, positive numbers over here.
Okay. 1,
so,
2, 3, 4.
Okay. So then we find that our score said negative 0.5. All right. So now we know we go with negative 2.58, right?
Okay, yes.
So where would negative 2.5? Okay, it's going to be right around between 2.5 and between 2 and 3. 2.5. 2.5 is about.
Do you label from the left or from the right inside? Oh, okay, from there.
So just in this example,
because that's what I did. Okay.
Okay.
Yeah.
Let's plot out
2.5 will be 2.58 in the middle here. Okay.
We're going to find negative 2.58 here, right?
Yes.
But then we found that our score is a negative 5. So we look.
No, a negative 0.5.
At negative 0.5, I'm sorry. Okay. Negative 0.
0.
Mhm.
It's in between -0 and -1.
Right. So then when we turn to negative numbers, now it's no longer, if this is our cutoff score, right, then we shade everything behind that line. Everything behind that line is now colored.
Behind where? Behind it,
Behind the cutoff score.
-2.5
Right.
to the left.
Right. Everything behind it is now colored. Our score was a -0.5, right?
Mm-hmm.
Which is actually normal and within the means. So if that were the case, then we would not be able to reject the null. We would have to accept the null hypothesis if that were the case. Okay?
Because it's
because it's because it's not as extreme. In our first example, let's see, I think this one was the one.
okay. So you reject everything that is shaded.
Right, that's the key. Everything that's shaded is except you reject the null hypothesis, and that means the alternative hypothesis is true. If it falls within the shaded area,
Mm-hmm.
you reject the null hypothesis.
Oh, I see. I see.
Okay, just like for this one, we're going to take the negative off of there and make that back into a positive. 2.58 for this one. And then we said, if this is our cutoff, everything back here is our rejection zone. Right?
I see. I see. Okay.
Okay.
Then anything over here you accept.
Right. And because when this was a positive 0.5, it fell within our rejection zone. We reject the null. But when we turned it into a negative, it didn't fall within our rejection zone. So we had to accept the null.
Okay.
Okay. You want to do one more of that, or do you have it, or you want to do one more of that one? Because the trickiest for me when it comes to that is the negative and happen to remember which one is actually closest to 0. So I have to write them out when it comes to the negative numbers. So let's go back to the 3 examples that we have. Let's get the screen up. Okay. So for the 3 examples that we have, and for example A, 0.01 with
Excuse me, just hold on just a second.
Okay.
I'll look into that later.
Which one? I'm sorry.
I have another class.
Oh, okay.
Yeah, I have another class going on that the professor is not really helpful. He will answer your question after you have submitted the assignment. You will ask a question and it will take her 72 hours to answer you. After you have submitted the assignment, then she will answer. It's crazy.
What class is it?
Yeah, it's introduction to gerontology.
I've never actually had gerontology.
Yeah. I've been waiting for that reply for the past 3 days. Never got a reply. Then I submitted my assignment that is due this night. I couldn't wait any longer.
Right. And now she replies.
So I submitted it, and I just But I'm just gonna look into that later.
Yeah. Okay. So back to the bell curve. Do you have that? Do you get the now the 34%, and then we'll talk about that as well because that did come up on the quiz, and I think
yes, and that the 34 the percentage.
Okay. Let me pull that one back up. Okay.
This is 3.
There we go. Okay. So if we say that 50, going back to this example, that 50 is our mean with a 25-point deviation in each direction, right? One standard deviation from the mean is going to contain 68% of the population.
Why?
Because we know that each direction, one standard deviation, let me write this out here. I'll put it at the top. So this is 1 standard deviation and 1 standard deviation. 2 standard deviation, 3 standard deviation, 3. Okay. So at the top, each one of the lines actually corresponds with a standard deviation, how much it is away. So this is -1 standard deviation from the middle, from the mean. And it contains 34, it's supposed to, if it's a normally distributed curve, it's going to contain 34% of the population. If you go back to the mean, go the other direction, 1 standard deviation away, just one line, that's also going to contain 34%. So if you go 1 standard deviation in any direction, you add these two together, and that's going to be 68. So one standard deviation contains 68% of the population.
So this whole drawing of, okay, let's see, in the middle is 50, right?
Mm-hmm.
So what is called 1 standard deviation is 1 line over. Is that what it means by 1 standard deviation? Is 1
exactly. It just means 1
line over.
Mm-hmm. Yep. So going back to where our mean is 0. Let's show all the lines out here. Okay. Back to where our mean is 0.
Why is the mean 0?
This was just the other problem that we made up. Just a random, just 0. We'll just say the mean is 0.
Okay.
Yeah.
Okay.
1 standard deviation is the next line over. So if you're going negative, we're going back. If you go positive, 1 standard deviation in the plus, we're going up 1 on the number line.
It's 1, yes.
Right. And so
okay, just go back to the other curve of the percentage. The center is 50, then 34, 14, and 2. 34, 14, and 2. Okay, 34%, 14. I do that, but I don't know what it means, God. Okay, here 2, the same 34, 14, and 2. Okay, so 1 standard deviation to the right is 34.
Exactly. Right.
And 1 to the left is 34.
It's 34.
So when do you combine it together, and what does that mean?
So let's say that we're looking for the amount. Okay, let's go back to the 50, right? We're going to use this 50. Okay, so let's say that I want to know what percentage of people I scored above. If I scored 100%, how many people what percentage of people are below me in my class? So the highest we can go is 125. I scored here, right? My nails are terrible. I'm so sorry. I scored here. This was my score, right?
Here, how?
at 100. Let's just say I took a random test and I got 100,
Okay.
right? The highest you could get was 125 on this test. I scored 100, right? I want to know.
So how did you get the 100 by
It's just a random number. It's not. It's just, I took a test,
okay.
and it was 125 questions, 1 point each. So the highest you can get is 125, with the lowest you could get being a negative 25. Somehow, just some kind of random. This is a very fictional example. I don't have any examples ready. So this is a very, very fictional example. 100 is not. These numbers aren't tied to anything. These numbers today we're using are just fictional. Okay, so I scored 100, right?
Mm-hmm.
The highest I could get is 125. I want to know what percentage of students scored below what I scored, right?
Okay.
So if I scored here, I want to know how many is here. I want to
Mm-hmm.
know how many is below me,
Mm-hmm.
okay? So in this example, we know the halfway of any normal bell curve is always 50. And you
Mm-hmm.
can add that up. You can add 34, 14, and 2. It's going to round about to be 50. We have to go into calculus if we want to do it any deeper. So they just tell us it's 50 right now. The other half,
50.
okay, the other half, we scored here. All right, so we want to know.
So would you add 34 and 14 into the 50?
Exactly. Everything except the last 2%. So we want to know how
Okay,
many.
yeah. Which is 98.
98%. I did better than 98% of the class. If I got 100 on this quiz that I could get 125,
But
I would have done better than
but
98% of the class.
I think you don't even need though they might need you to show work. I don't know, but ordinarily
It's
you can just
do it in your head.
just figuring out that if I score 100,
hmm
then people that scored below me, well,
So
well, it
let's
could be,
say
I don't know.
let's do another
Okay,
one. Let's say we scored 7 on the same chart.
okay,
We scored. Wait a minute, baby. We scored 75. Okay. I
okay.
want to know how many people. What's that? I want to
So we
know
have a 75.
how many people did better than me.
So we
Okay,
are at 75 now, and that's
75 is here. Okay,
50, 75, 100.
so I want to know how many
Okay.
people did better than me this time. So what am I looking for this time?
Looking for 14 and 2.
I'm looking for this side.
Yeah, the 14 and 2.
Right, exactly. So 16% did better than me.
Mm-hmm.
Good. That's it. That is it.
Just that?
That's it.
Let's see.
And they try and trick us, but that's all that's to the 34, 14, 2%. Good numbers to remember because you can roughly estimate how many,
Just
what
give me a
percentage.
second. I'm gonna make it right.
Okay.
100%. Um, score higher you add. Good lower. Okay.
Okay, good.
Got it.
So that was all to week. So let's just look at the questions one more time to make sure that we didn't miss anything. Okay, so that's all the week 3. We answered A. We know how to get the Z cutoff scores. We have the 95. We know those, right?
Mm-hmm.
B, you already knew how to get that. Z,
Yeah, well, it's the same process. So
simple as
I
that.
think I'm good with that.
Okay, good. All right. So let's see. On to week to this past week, week number 4, which
Yes, number
was
4.
uh sampling distribution of the sampling group.
Can you pull it up?
So what I did is actually I got give me 1 second. All right, there we go.
Okay, yeah, that's a whole lot of question this week.
No, we're
This
not. We're
last.
not. Yeah, we're gonna start really simple with question number 1 here. Is what we're gonna start with.
Yes, I need to. Let's see. Because I keep doing the work and the professor keep telling me no, do that.
And what you're gonna find out once you actually get it, you're gonna realize how simple. It's so tricky. And
Yeah,
yeah.
because especially this one you just showed me now, the percentage.
Mhm.
I can, yeah, I will draw the curve just like what I saw in the book.
Mhm.
I do 2%, 14, but I don't know what it is.
Yeah.
So I think some classes are really not good online.
This is. I don't know. I don't know how I would have done in class. Probably fine, but I was really nervous about this being online
Because
as well.
because probably maybe if I have seen somebody that just walk me through from week 1,
Mhm.
maybe I would have done better.
Yeah. Yeah. Have
The
somebody.
way
Yeah.
I joined the peer section the first week or second week, I didn't even understand what she was saying.
Uh, well,
Yeah,
we've got Google. We've
I,
got
I
Google.
kind of
So
get you now because I kind of I'm like asking you even the stupid questions. I just keep asking you
there's no stupid questions.
just to make sure I get it, but I may not be
Yeah.
able to ask him.
Well, I'm definitely always here, and like I try to get the work done the week before, or at least the weekend. I try to get the reading done, so I'm already ready. I'm halfway done with next week's reading already. So I try to keep ahead of it, but I'm always here. If you ever have any questions, I'm always here. You can either
It's
shoot it
more
an
of
email.
reading. It doesn't even have much examples.
No, it doesn't. And what I do as well is I do a lot of YouTube videos.
Okay,
Yeah,
okay, yeah, that may be an idea. Now I'm
yeah.
telling you, algebra is really sounding better to me now. Because with algebra, I used to get help from this other website. I'll just go, just just to get the formula and get it done. But this, I've been searching and I'm not really getting what I want.
Yeah, and the formulas are really hidden in the work, and then you got to kind of fight for the formulas. So that's what we'll do for this first week. Well, and I've got the formula. I'm sure you've got the formula how to figure this out. But the formula to me didn't help until I started putting it into pieces. So that's what we'll do. We'll go to question 1 with a sample size of n of 100. Produce the sample mean, which is x bar, is
Where is
16.
this from?
This is where did I get this from? The University of Dallas, and the answers are all listed here, but I know how to get it. But do you want to look at the? We can look at the class homework if you want to do that.
Yes, if you
Let's
can,
see.
because yeah, we can still go through
Okay,
this when we're done with
there we
that.
go.
Okay.
All right. So is this the right week? Let me make sure I've got the right. Nope, that's the wrong week, I think. Um,
Yeah, it should be at the top after
there we go.
yes.
All right. So assume you have a population which has been measured on a psychopathy scale with a
Mm-hmm.
mean of 14.
14.
Mm-hmm.
So I think this S is standard deviation, right?
Right. Mm-hmm.
Okay. Yeah, of course, that's what I thought.
The
Okay.
distribution of the population is unknown, but is likely not normally distributed. Okay. Which, in the grand scheme of what we're doing, it actually doesn't mean anything. So don't let that scare you, because the sample, what we're doing now makes everything normal as long as you have a sample size of 30 or more. All right. And in this one, we have a sample size of 49. So it will end up, the question A what is the shape of the distribution of the sample means it will be normal.
9. So yes, it's normal. Why?
And it's because the sample size is 49. Now we're going into, what's the name of the rule?
Because it's above 30.
About 30, right.
Above 30.
The central limit theorem. Central limit theorem is what it's called.
So where are we getting this study from?
It's the central limit theorem. This smart guy a long time ago did the math and figured if you got 20, it's still not quite right. But
you know what? I suck with this statistics. I don't even know. Okay, it's above 30.
Yeah.
Okay.
Is what this the central limit.
So anything that is above 30 is normal.
Is normal. Supposed to be.
Okay.
Supposed to be. Now, I'm not going to get into that, but I have problems with statistics because I don't agree with everything. So we will say supposed to be. Everything above 30 is supposed to be normal. Okay, so in our example, we have 49. So for question A, what is the shape of the distributions of sample means? It's going to be normal because of the central limit theorem, which tells us anything above 30 will supposedly be normal.
Okay, so let's assume it's 150, it's normal.
It's normal.
Yeah, but if it is 15, it's then
it may come out. And I'll show you why. I hope I can find this one. Give me 1 second. It's the perfect, oh gosh, what is it called? Let's see. Give me 1 second.
Okay.
Here it is, I hope. No,
it's really making sense.
Let's see. Actually, I know right where. Give me 1 second. I'm going to pull it up because this will actually visually show you what's going on here. Give me 1 second. Yeah, that's fine.
Double cheeseburger bacon.
Here we go. Any of them. Double or bacon. Thank you. All right. Now check this out. Right. This actually helps you visualize what's going on with the central limit theorem. Okay. So let's say that we have a very weird distribution, not normal whatsoever, right? Can you see this? I hope you can see it.
Yes, I'm seeing what you're doing.
Okay, so our distribution, we have a very weird distribution. We went out, we took a sample, and these are the numbers that we got, right? So if we have a small number like 5, if we only take a sample of 5, what's going to happen is it's going to end up looking just like it looks. It's not going to do much to it at all because there's no way you can get a number from here if you take a sample of 5, right? If we take a sample of 10,000 and make it into a normal distribution and make it sample the means over and over 10,000 times, what's going to happen is it's going to come looking like a normal distribution. Okay? Did you get that? I'll show it to you again, right?
Oh, I didn't get it. Sorry.
Okay, so we have a number of 5. We're taking 5 samples, right?
Mm-hmm.
So on this one we'll take 5, and on this one we'll take 25, right? And let's take 5 samples. Animate it out. All right, this is what happens.
So when you put in the 5, the thing will just show you, or what?
Say that again. Where am I putting the 5?
Like the mean is 5. So I don't understand the
mean. No, the mean is not 5. Right here, the data is saying that this is 0 to the left, all the way to 32.
2. Mm-hmm.
Okay. So the mean, the mean is 13.72. If you look all the way to the screen, can you see my pointer? I don't know.
Yeah, I do. I see.
You can see the pointer. Okay, so the mean is actually 13.72. All right, with the data that we did, we have a standard deviation of 7.89. These are all just completely
Yeah.
random numbers that I put in here, okay? And we can change that as well. Let's change that, right? Let's change this. All right, so let's do it like this and add some more numbers in here and make it look like that, right? So now we have a mean of 13.38 with a standard deviation of 7.20. Okay, it's completely not a normal distribution, right?
Why?
A normal distribution is a bell curve, and this is not a normal bell curve. It's
Okay, I
missing.
see. Yeah, this
Yeah.
is, yeah, got this
Tails are tall. The
is
tails
up here. This is okay. Yeah, I see what you mean now.
Okay, so then if
Mm-hmm.
a sample distribution of the sample means, which is what we're doing this week, is taking whatever number, in this case it's 5, okay? We're taking 5 numbers out of here, 1, 2, 3, 4, 5. Okay, let's clear it. We're taking 5, and I'm going to animate it. So it's taking 5 random samples, right? Once it takes the 5 random samples, it falls to the bottom, and then this is how it looks, right? With a number of only 5, taking 10,000 samples, let's see what happens. It gets really close to a normal distribution because we took so many samples. Okay, let's see. Let's keep it with the mean for now. All right, so let's clear this one. So if we go from this is a normal bell curve here, right? Take 5.
And what number did you use?
I didn't use anything. They give you the numbers here.
Okay,
It's
okay.
16 and 16 with a standard deviation of 5.
Okay.
Okay. So then this would give us a normal bell curve here at the top. Right? So let's animate it a little bit. Let's pull some samples out of here. Let's pull 5 samples. 1, 2, 3, 4, 5. And then it averages out the samples and then puts the average of the samples here. And you remember how to average. How many did you get? You took 5. You remember how to find the mean, right?
Mm-hmm.
Okay, so it took 5 out of here, 5 random numbers. It averaged it out, found the mean, and the mean of these 5 numbers is here.
Mm-hmm.
Okay, so let's do it again. Let's take another 5. Let's animate another 5 out. 1, 2, 3, 4, 5. The random 5, the average is very, very close to this one. Okay, the median.
So what what is this? I don't know.
This is what we're doing this week. This is what we're doing this week. The sample standard deviation of the sample means. We take samples of our sample. We take samples of this sample, average it out, and then compare it. All right, so let's go back here.
I see.
All right. So, all right. So we've already answered the shape of the distribution is normal. Okay.
Yes.
What is the value mean of the distribution of mean?
Distribution is 14.
It's 14. Okay. And the reason that it's 14, the reason that's 14 is because after you take out these samples, it's supposed to, okay, with a large enough sample, let's take a bigger number so that we can see it. Let's say 20, right? With a big enough sample, you'll see, and of course we don't have a sample of 49, so we can only do this, let's do it as big as we can get it with 25, right? You'll see that the mean is going to come really, really, really close, okay? The mean here is 15.99. In our big one, it's 16. Okay? So when you take 10,000 samples, it's going to average out to be almost the same. Let's animate it out, right? So it's taking all these samples, average, and then it's going to take them all, right? And then eventually it's going to average them out and plot it down here, okay? Once it plots it, we can take that, and then that's the next step that you'll see, okay? So the value of the mean of the distribution of means for right now in this class is going to be the mean.
It will be what?
It's going to be the actual mean of the sample. For B, the value of the mean of distribution of means is going to be the mean.
Okay.
Okay. Once you get to calculus and above, you'll start actually doing the numbers and see that it's 1599 instead of right on 16. It's not.
Oh, instead of the 40.
Right. For our class, it's going to be the mean is always going to be the same mean. Okay. So the value is the same. It's going to be 14. Okay. The next part comes the tricky part. Question C. What is the value of the standard deviation of the distribution of means? What is another term for this value? Another name for this value is the sample error of the mean.
The what?
What this means, this question is asking us to do this. Okay? What we visually just saw, this question
it's actually for... Okay, let's see. So what?
So what we have to do now is find a formula that we can plug numbers into that will fit.
Okay,
right?
For the standard deviation of
to find the standard deviation. All right. Do you know the formula?
I saw something. I don't know which formula I used again.
It's a really long, complicated-looking formula.
There's one formula I use, which I don't think I get them. I don't know. Let me see. Sample mean agent is the form.
Here we go. It's going to be this formula.
Which formula? Which formula is this? X what?
Can you see it on the screen?
X equals to square. Is that square root?
Yes.
And what is the other?
The E, it just means the sum of
X minus X is squared. And what is the... Is that divided by?
Yes.
N minus 1?
Right.
And what is down there?
These are my own personal notes. So on mine it says see page 2. So then for my own personal notes,
is that just see that formula somewhere. That formula. No, okay, no formula. What is it? The confidential interval. Okay. Confidential interval.
Now you will need
the formula is square root E into X minus X hyphen square divided by N minus 1.
Right. Good. And so what that means, I broke it down into a 4-step problem. So the first thing that you need to do to figure out the standard deviation of the distribution of means, or the standard error of means, is find the population standard deviation.
Oh, so the another name for the standard deviation of mean is the standard error, right?
Right. So let's go back to this screen. Okay. And the first thing that we need to do is find the population standard deviation. Okay. Which is going to be 3. Okay.
3?
Yes. right here.
Why? How?
Uh,
Did you plug in the numbers?
No, I'm walking you through the equation. Unless you want to plug in the numbers, I don't know if you do it in your calculator. If you do it in your calculator, you can go ahead and plug in the numbers. But for me, I had to break down the equation itself, the formula itself, to figure out.
Okay, yeah, if you can, because I'm so which one is E, X, and this? Because I want to know.
Okay, let's see. Let me go back to that equation, because when I'm figuring this out, I don't use the equation. I have the equation just to remember what it looks like.
So how do you do it?
Okay, the first thing that you have to do is find the population standard deviation, which is the sigma. It's the, or in this one, it tells you S for standard deviation.
Mm-hmm.
Okay, so that's going to be 3.
Mm-hmm.
All right, the next step you need to do, this formula is telling you the next step you need to do is take the square of that.
Of 3?
Yes.
Which is 9?
It's 9. All right. The next step, and you should write these steps down, because it's every time it's going to be the same steps to understand, to find the standard deviation of the sample means. The step 1 is identify the population.
I did that. Let me just check my notes. I did something similar. I'm just kind of walking. I don't even know what I'm walking through. I think my MATLAB or something. That's something that it looks similar to that.
Yeah, probably my MATLAB. Yeah.
I did something similar to that, but I can't. Yeah, the standard deviation of distribution of mean. Oh, isn't I used a different formula here. Use a different formula. I found the variance first.
Yes.
Then when I find the variance, this was my variance 400.
And then you just take the square root of the variance.
Yes.
Exactly. That's the whole formula.
Yeah, no, the square root of the n of the population is the variance.
Okay, now I'll let you do it. I don't want to confuse you on this, so let me see how you do it, because then I
did something, but I don't know what I don't. But I know I used the a formula of I don't know how to pronounce this. This that is like QM. What do you pronounce that formula? I don't know what it is.
Maybe
so
it's
this formula that is like a Q
with the squared. Q square M.
Yes, it's like a Q square and M.
Yes, that's this formula.
So that equals to the square root of that, which is equals to the square root of that Q2 over N.
Okay, now if you can figure out another way to do it, I've made it into a four-step problem.
Okay, let me see how I did. I did it. Okay, I did. Okay, yeah. Let me just give me a second.
Okay.
This, which is the variance. Let me see, because I was looking at my note. Then I did 400 over 2. The variance over the SD is this. Then the variance over the population. That's what I did. Variance, which is 9 over the population, which is 49. Let's do it here. Equals to population is 9 over 49, which gives me equals to 0.184. Okay, square root. Okay, I got 0.429.
Let's make sure that sounds exactly correct. Good, 0.43.
Okay.
Good, so that's the answer for C.
Because I used this, I don't know, can you tell me the name for that formula? That's something square root M.
The sigma, the Q thing looks like a Q.
Yes, yeah, that looks like a Q.
Q squared M. It's looking for the standard deviation of the distribution of means.
Okay, so I did the standard deviation square root, which is 9, which is the variance, then the variance over the population.
Okay, I do it different, but we come to the same answer. I do it different, but we come to the same answer, and that's all that matters.
Oh, okay.
Yeah, that's all that matters. Okay, and then so for question D, what proportion of the sample means are greater than 19? Okay, and for that, we need to do another formula.
Okay. So which form the proportion is greater than 19?
So we are going to be looking for, give me 1 second. All right, so we are in this one. We're going to be solving for what I call solving for x. So we're going to be doing you remember the long equation, m plus z plus the times the standard deviation.
The what equation?
I call it solving for x, and I believe that's what it's called. Just solving for x. M plus z times the standard deviation.
M plus z times standard deviation. Okay.
Until that.
Okay.
And then what you get?
Okay, so which is 14 plus 3? No, 14 plus, and where is z here?
It's what you just found. What you just found.
Oh, is that the z?
Wait a second. Am I doing the right one? Give me 1 second. Page 4.
Okay.
I'm sorry. X minus m.
Excuse me? The formula?
Yes.
Is what?
X
minus m
divided by the standard deviation, and then that will give you your z-score. So in this one we're looking to find z. So take your x minus your m. Your phone. So let me do it with you, yeah? I didn't make a pencil. Yeah. Oh, yes, I did.
Okay.
So let's pull that one back up. All right, so your all right, we have 14 times. Wait a second. No, I think I did have it right. Give me 1 second. Let me do this equation myself. 14. Okay. So then this is how I do it, and all kinds of random numbers in here. And make sure I'm doing the right equation. Oh. 14. I'm sorry, I'm all messed up. You can tell it's dinner time here. I'm really hungry. 14. times, and this does not look like it's the right equation. Give me a second, I have to figure this out. No, that's not the right equation. So it is the x minus m over the standard deviation. Give me a second. And that doesn't sound like the right equation either. X listed over the standard deviation. Yeah. Pull up the numbers. Okay. Wait a second. 1.67. No, I'm doing something wrong here. Give me a second.
Okay.
Because it takes me a minute to remember. It takes me a minute to remember which formula I need to do. But I know that I'm looking for some kind of z-score. That's a z-score. 1.67 is definitely a z-score. So I'm going to be minusing something and dividing it by something. But what and what? I know 0.43 is going to be there. 1449. Let me see. This one as well, I had to. Did you happen to get this one? Did you find this one, Azamar? Did you get this? Did you get this answer?
What, the D, right? I didn't even do it.
Ah.
Yeah, I didn't even try because I don't know what it's asking about. And let's see.
49. Proportion.
Change.
Oh, wait a second. Wait a second. Okay, let's go and look at the classrooms where I can see what everyone said here. And I know that I'm searching for a z-score. Let's figure out which one. Okay. Yeah, 19 minus 14. Where did we get 19?
So
Divided by 3.
X is 19.
I'm trying to figure out where we got 19.
The 19 is it the 19% is asking about?
Duh. Yeah, I'm like, look, I am really hungry. I knew I was doing the right equation, but I could not.
19 minus 14 over 3.
Yes. I knew I was doing the right equation. We're solving for
5
Z.
over 3. Which is
And 3 is the 3.
I think I did, but not is that the D? Yes, I did. Yes.
Yeah. Okay.
Yes, but she said no when I posted the answer.
Let's check. Check.
She said no.
Let me check.
I remember I did it because you gave me the formula, remember?
Let's see.
And I did it and she said no.
Now, I haven't heard anything back.
Yeah, let me check what she...
Same answer.
She answered.
And let me see.
Because I know she did say something else.
Okay, she responded to mine. I think this was the first one that I did. Let me check. She responded.
I don't even know what that person... I think that person checked on the table.
When the first one that I did, I got 3%, and that ended up incorrect. And then I did it again, and let's see. Yeah, this was correct the second time around. I highlighted it so she could see it, and she did not respond. Let me double check. Let me just double check.
Yeah, that's what I'm still double checking because she said something on mine. Let's see.
Let's see.
Because that's exactly what I did here.
Okay, this is the one with the comment.
Oh, where is it? Okay.
All right.
Cassandra White.
So here it is. Okay, so this was the one that I did originally. And then she came back and said, here's the equation. And so when I did the equation, which you just did the equation, we got 1.67, which is the answer.
And she said what?
She has not responded. But
Can you give
this
me
is when I
can you just give me a second, please?
Okay.
Because see here, you see, I did here. I did for. Oh, I see. I see why she said no. Guess what I did?
What was that?
I turned it all around. I did 14 minus 19.
Oh, okay. Yeah. Okay.
I did 14 minus 19 over 3. That gave me negative 1.67.
Okay.
Yeah. Okay.
Yeah. So we got it. Okay.
Yeah, I see why she said no.
Yeah.
Okay.
So we got it. We got that. We got that.
Mm-hmm.
All right. So
Okay.
let's see. Let's go back to the question.
Okay. Sorry for taking your time. I'm just
No, it's okay.
Just wanted to make sure why she said no.
Yeah, it was the backwards. All right, so we got D.
Yes.
1.67. All right.
E is another. What did I get? I get something for E. I got no which answer I got, but she said no too.
But now you know the equation.
Yes, for the D. For the E, what did I do? I got 43.26 for E.
For E, let's see what I got here.
And she said no. I did 14 plus the first. Okay, I used the C.
Oh, right. You used the wrong one. So then, okay, so plug the numbers back in.
For what? For the E?
Mm-hmm.
Because E is what formula is that? That is M plus Z.
Let's go back to C. What'd you get for C?
C, I got 0.43.
Okay, and D?
D 1.67 now.
Good. All right, now on to E. What value? Okay.
So I did M plus Z times SD.
Give me 1 second. Let me check the formula for E. All right. M plus, yep, that's the formula. M plus Z times S, that's the formula.
Yes, then I did 14 plus 0.4, 14 plus 0.43 times 3. Oh. So why did I get, oh my God, let's see. Why did I get 43.26? Because that's not what I'm getting now. But that's what I posted for the 3.26, but that's not what I'm getting now.
What are you getting now?
Because this is exactly the same numbers I did. Okay, 14.40. Okay, times 3. Yeah, 43.26. Yeah, so check it now. So what did you do?
Let me see now, and we can pull up. I can pull this up so that you can actually see the formula as well, right here.
Yeah, I got the formula, but I think the figures I'm plotting in may be the problem.
Okay. Give me a second. Here we go. All right. So 2.5, we have to first find that number of 1.96. And where does that number come from?
No, that is the cutoff score.
Exactly. So
oh. Oh, is it what? Okay, that's what you use
Mm-hmm.
as what?
That for we're doing
So you did this times 3 minus this plus. Huh. I thought we are using m plus z times sd.
wait a second, because we actually have to find, give me 1 second. So we are solving for m in this one. And so I'm solving m. Well, no, go back in. I'm not done yet, okay? Geez, I keep getting so backwards. Let me go back up to the right question. What value sample mean separates the high is 2.5. So 2.5 is, for this one, you're actually going to either go to your table or just go to the original one that we made. All right, so let's find. Give me 1 second. Give me 1 second. Let's get another example. Yeah. Okay, so 1.96 is from the cutoff score that it's asking us for.
So you use that as z.
Right. Z cutoff is the cutoff score. Right. Right. Times the standard deviation, which is 3, plus the mean, which is 14.
So did you get 18.96?
19.88.
Why? You got 18.96.
So we multiply 1.96, which is the cutoff score, to 3, which is the standard deviation.
Okay, 1.96 is 3, which is, yes, 5.8.
And then add that to the mean, which is 14.
Which is 14. Oh, 19 point. Plus, okay, did 14 plus 1.96 times 3. 14 plus, I get 5.88. 1.96 times 3. 5.88 is supposed to plus 14. Yeah, 19.88.
Plus 14.00.
14 point what?
0.00. There you have. I don't know why it's not.
So you have to add 00 to the mean.
If how can I explain this? How can I explain this? In order to calculate this, you have to turn not everything, but 14 into a point, 0.00. Just have to add something behind it because of the 1.96.
Okay, so that means it's 14.00 plus 5.88. It's still the same answer.
What answer? 19.88. That's the answer.
Yes.
And that's the answer to E.
To E, okay. Let's see the E. Yes, what did I get here? Okay, yeah, I did it the other way. I did, I got 43.26. I did it all wrong. I used the wrong figures.
Okay, and then back to. I'm so sorry, I'm chewing your ear. Do you want to continue tomorrow?
Are you tired?
My dinner was just brought to me, and I don't want to chew in your ear. It's so rude.
Oh, okay. No, if you
we have 2, 3, or what? Let's see.
Yeah, so I think the ones I think I may need. Okay, let me see if I can point out. I think numbers. Let me see the one what is conventional consumption. Let me see. I think I have problem with this 7 or something. Yeah, the 7. Maybe if you can quickly.
Okay.
There's a research and yet I did it. What is the 3 pressure? I don't know what is the cutoff for the hypothesis text. What is number C? 7C. What is KU?
What are the cutoff scores for the hypothesis test? That's the Z. It's let's see. It tells
It's
us
what?
right here the 5% significance level
Mm-hmm.
is the 95%. So you go back to that table, 95% with how many tails, how many, and from question A, you would know if you're looking for one tail or two tail from the hypothesis. You would know if we're looking one way or both ways. So in this one, they're determining to see if the child has any kind of reaction. So we're looking for two tails. So we're looking if they react positively or negatively. So we know that we're looking for two tails with a 5% significance, which is a 95% confidence. So 95 with two tails is 1.96.
Okay. Yeah, because 5%. Yeah, in order to conduct the Z text.
On the
So how do you
Z-test,
conduct the Z text on this? Are you gonna use the 5?
the Z-test was that long formula
Which long formula?
where we're looking for the sample distribution of the sample mean.
After the sample mean, okay.
Mm-hmm.
Is that the same question?
For question D,
D.
7D,
Mm-hmm.
we then find out what Z-score, our distribution of sample means has.
So yes, my question is the what is it again? Is that the same as the Z test?
Question D, yes. Let me just double check, and we can look at this. Yes. Mm-hmm. Let's see.
So
No. Z-test is searching for Z. So it's going to be something divided by something. Whenever we're doing a Z-test, it's looking for a Z-score. So then you have to figure out which table, which formula you have that will fit this equation. So in this equation, searching for the Z-score is going to be some kind of mean minus something over some kind of standard deviation. Okay? So for this Z-test, we have to figure out which Z-test are we going to use. So we have the mean, which is 13, minus the sample mean, which is 14.
Okay.
With from question B, we know that the standard error of the mean in this case, if you did question B and got the standard error of the mean, we know that that is 0.43. So we divide 13 minus 14 divided by the standard error of the mean, which is 0.43.
0.43?
If you did question B, then
which question B? The first, the number 1?
No. This second one that we haven't talked about it, but I don't know if you did it or not.
No. What are the 3 characteristics of distribution of mean? So
and we know that one of the characteristics is the standard error.
Does that involve calculation?
Yes.
I didn't do it.
Because it's asking for the what's the 3 things it's asking for? The standard error, which is that long formula. Okay, so the mean of that we know is 14. the shape. You can tell the shape by how many samples. So if it's over 30, right, we know it's normal. And
for which question?
I'm looking at question B. The 3 characteristics of the distribution of the means.
Say one is what?
So we know the mean is 14. The
Mm-hmm.
shape is normal because it's over 30. The
Over
sample,
30, yeah.
we have 49. And then the standard error is the long calculation where you have to find the square and the square root and all that stuff.
Mm-hmm.
And if you've done that, then have you done that part?
No, but I can maybe after I can go through it.
Okay.
But is the standard error where you got the 0.43?
Yes.
Okay, I think I can maybe when you're gone, I will just go through it and see if I can get that answer.
Okay. So we've got the mean minus the sample, or the sample mean, or mu, the smaller, but minus. Let me look at this.
Which is minus 2.33.
Wait a second. Give me a second. Right. It's negative 2.33. Right. And then so from that, it continues on to ask you question E. Is 2.33 bigger or smaller than the cutoff of 1.96?
The cutoff.
The cutoff
smaller.
is question C.
Oh, no, the cutoff now should be the minus, right?
Mm-hmm.
Should be the minus 1.96.
Right. Mm-hmm.
It's higher.
And then so from that, what can you say?
Reject it.
There you go. There you go. You reject the null. In this case, we were testing to see if what were we testing?
So why are we rejecting it? Because it's more extreme.
Because it's more extreme.
Okay. They construct the 95% confidence interval based on the result of this study. I think I did something like that. Somewhere. Yes, like here, 95% more. The 95% of this is where they use this formula of QM whatever. Is that it?
95%.
Yeah, they use
the 95% confidence interval. We use another formula. It's the confidence interval.
They use the Is it where they use the QM square root of Q square M?
Give me 1 second. Let me look at that.
So I don't know which formula you're using.
Give me 1 second.
Or is it where they use the lower limit and upper limit?
That's it. Lower limit, upper limit. That's it exactly. Lower limit, upper limit.
I did a lot of rough work here.
The sample mean is going to be the formula of the sample mean plus or minus the confidence, the lower and upper limit, times the standard error of the mean.
So in this case, we are using minus 1.96, right?
Let's see. 95% or 5%.
Are we using the positive?
1.96. We're gonna use 1.96.
Are we using the positive or negative here?
So in the end, once we get our score and we see that it's negative 2.33, we go to the negative side.
Yes, exactly. That's why I'm acting. So we're gonna use the M plus negative 1.96.
Now we do both. We have to get a value for both. So we do M plus 1.96 times the standard of the mean. Get that equation. The very second equation is M minus 1.96, and those two numbers are your two values.
I know, but I know. My question is, we are using the positive cutoff score here, not the negative.
Are you talking about to get understand if we accept or reject the null hypothesis?
No, my question is. No, the cutoff score here is negative 1.96 or 1.96.
Mm-hmm.
So in this calculating the CI, are we using the negative or positive?
You use both.
No.
Yes.
You can understand my
Yes.
question.
Yes. Yes.
I know we use the pos we add on the upper level, then we minus on the lower level. But I'm asking about how will I put it? I don't know how to put it. Okay, our mean is what? Our mean is let's see, what is our mean here? What is our mean? Let me see how I can put it so you understand what I mean. Example for my children. Mean of is 13, right?
It's 13.
13. Okay. So my question is 13 plus 1.96 or minus 1.96.
So we have, to find the upper limit, we have 13 plus 1.96 times the standard error of the mean.
Yes.
To find the lower limit, we have 13 minus
0.4.
Wait a second, you're missing it, okay? For the lower limit, we do the same equation, 13, except this time we minus. So you have to do both. You have to do plus and minus. Because
yes. But that is not my question.
Okay.
But I guess from what you're answering, I think I got my answer. My answer was the inside the 1.96. Why not use negative 1.96?
You do.
How?
How can I show this to you? Let's see. Give me 1 second. I have to show it to you so that I can make sure that we're understanding each other. Give me 1 second. Oh no, it doesn't look like it's going to let me. Okay, I'll figure out another way. Give me one. Okay. Okay. So, can you see it? Okay. So we do both 13 plus 196 times the standard deviation. That gives us the upper limit.
Yes.
To find the lower limit, 13 minus 1.96 times the standard deviation to give us the lower limit.
Yes, that's still not my question. I understand this right.
Okay.
My question here is, we are using the cutoff score where to reject the null is either minus 1.96 or 1.96. I see.
Here?
I see. Okay. I think I get it now. Okay. Okay, I think I'm fine.
Okay. So you see here that we have both of them because we don't know yet.
Yes.
And then once we actually do our test, we see that we're actually going to use this to determine.
Okay.
Okay. And then this is a completely different question. This is a different question. Okay. But
which one is a different question?
Not as the same numbers, but I don't want you to get confused because these are two different formulas. These are two different things. I don't want you to get confused here from this and this.
Yeah, I know. It's two different things because that is number D, which asks for what? What did they ask? Ask a different question.
Would you reject or accept? And then from that, construct the 95% confidence interval based on the results from that we got from the study.
From the yes. I don't know which. Okay, 7.
Okay. Now from there, let's see. I had some sample questions that I did want to show you. Were these that actually take us through all of those things? But it seems like you have that.
Of what?
Like question number 12, based on a certain brand of tortilla chips that claim to have a net
12
weight of
from
4.
where? Where is this 12 from?
This is a random question, just a practice question to help
Okay,
you.
okay. The one you got first. Okay.
And it's saying that they normally have a net weight of 14 ounces, but the bags vary. But they're
Excuse me.
normally distributed. Mm-hmm.
Excuse me, Karina.
Uh-huh.
In case you wanna eat your dinner, maybe we can, if you have time tomorrow, we can go through it and maybe this week's work. I don't wanna
That
hold you.
sounds great. Sounds great. I don't know what happened to JB. Now I feel bad because he was having a lot of trouble.
I could do this all night really because he's really thinking it, but I need to let you go.
Okay. Well, look, at any time, send me an email, anything. My computer is usually right near me, and
Okay, so
I can send you the notes that I have or anything, anything that you think. Well, hey, I've got a lot of videos too from YouTube, so if you think
yeah,
that will
just
help
let me
you.
know maybe tomorrow or Tuesday. I mean, anytime you can, maybe in the evening. Just let me know so I will check myself and reply because I really need. I have really learned more than I have throughout this class. This is the best. I mean, I just
Good.
yeah, because everything we did now, I think if I see any question relating to, I can really do it. It's
Mm-hmm.
really sank into my brain. So I would
Good.
like to do it again soon.
Good. Good. Well, like I said, I've already started next week's, and it's actually pretty simple. If you can understand this week's stuff, then next week is going to be a breeze.
And we
Next
have
week
a
is
quiz
really going to
next
be a
week,
breeze.
right?
Yes, it's another quiz next week.
Oh, this week actually.
Yes. Oh my goodness. Okay. Mhm. So it's
Yes.
going to be this stuff on the quiz. Yeah. Mhm. So if you want to get together before the quiz, I'll try and get out with JB again. And
Yes, please. I would love to because I just wanted if you can like walk me through as you did tonight. So just kind of.
So how about we'll do this? We'll look at the quiz, and if there's nothing about type 1 and type 2 or about this week's stuff on there, then we can just go over this stuff anytime you're ready.
Yeah,
And
yeah,
yeah.
I would do that. I would just as soon as possible download the
Okay.
quiz and look because I think it should be from the previous weeks, not this week.
Yeah. Right. Hopefully, yeah. You're right. You're right.
Yeah, or we can do
Yeah.
like if it's something that I'm finding difficult, we can like construct a different question altogether.
Right. Exactly. Right. Just to make sure that we got the formulas and things like that. Yeah.
Yes, yeah, because that's the most important thing
Right.
to be not for anybody to solve the particular question, just to get the
Just to make sure. Right.
okay.
Sounds good, lady.
Yes,
Sounds good. Sounds good.
thank
So,
you so much.
no problem. You have a great rest of Sunday night, and I'm going to enjoy my dinner and watch TV. I'm done with work for the night,
Okay.
So, have a great night, and we will talk to you sometime this week.
Okay, thank
All
you.
right. See you later. Bye.
Good night.